Okay, how did you go? Here are the solutions to those programs. We'll start with bug.c. Here is bug.c rewritten such that it is now bug-free. I guess it should be renamed bugfree.c. Firstly, there was a close comment here, and it obviously needed to be moved down here. Next, we forgot the line #include_stdio.h. Next, this line was wrong because it had a colon on the end. Next, there was a single equals sign here instead of a double equals sign. We'll have a talk about in a moment as to what that causes the program to do. Clearly it's not going to work. There was a semicolon on the end of that line, which I'm sure many of you had trouble with. There was no semicolon on the end of that line. There was a \m here instead of a \n, and the word otherwise was used here instead of the word else. What else? I think there was another \m here. This was f_flush_stdio instead of s_flush_stdin, and we had the word char inside the brackets there. Finally, there was a round bracket on the end of main instead of a curly bracket. If you got the program working and it worked as you expect, then you probably got rid of all those bugs. You may not have gotten rid of the one here, the equals equals versus the singles equals. Okay, the third exercise that I posed to you actually talks quite considerably about this, so I'll leave the discussion about that particular point until then. Next, let's have a look at the other problem, the second exercise. Okay, this particular file is called agesolon.c or agesolution.c, and the task is to determine if you are the chosen one. Now, there's really only one juicy line of code in this entire program, and it's this line right here. It's the rather sophisticated if statement. We're doing a string compare to see if your name is Bruce. If it equals 0, then your name is Bruce, so that's good. Finally, we're saying, well, your name, it's not just enough to be called Bruce, you also have to be not a teenager. So let's have a look and see if that is the situation that we're coding for. Okay, now clearly the highlighted code represents an age that is not a teenager. If you're less than 13 or older than 19, you're not a teenager. Notice I used the word or there, or older than 19. That's the or right there. Okay. Now, what many of you might have forgotten to do is surround that extra code in brackets. You may have simply said, if your name is Bruce, essentially, and your age is less than 13 or your age is greater than 19, and suggested that that might solve the problem. That might be the solution to the program, and it's not. It's almost right, but it's not. Can you think why not? Well, I'm sure the ones of you that have solved this problem correctly by putting the brackets around will have the correct idea about this. If you don't believe that that doesn't work, let's compile it and test it and check it. First we compile it. Okay, it compiles. Please enter your age. Alright, I'm going to try an age like this, 60. Okay, that's not a teenager, so that might be the chosen one. But let's do the age, the name as well. So let's call Tom. Oh, you are the chosen one, and your name is Tom, and you're 60. Now, how can that be the case? Let's have a look. There's the line of code there. We printed out this line with Tom and 60. So let's go through it and see if we can figure it out. Okay, first of all, did this evaluate to a true? No, it didn't. It evaluated to a false because it was Tom. Strucump would have not returned 0, it would have returned probably a positive number, and so that would have been false. Okay, so that's false, and then we say, and age is less than 13. That's the next bit, and age is less than 13. So is age less than 13? Well, we entered 60, so that's clearly false as well. So we've got a false, excuse me, I'll do that again. We've got a false here, and we've got a false here, and we're ANDing them together. And a false is going to give us a false. So all of that is going to be false. We say, all right, if that is true, or this is true. Now, is this true? Yes, this is true. Age is greater than 19. Age, in fact, was 60. So that's true. So if this is false, this bit, and this is true, this bit. So a false or a true is a true. Can you do that in your head? Let's have a think about it. For those people that don't get a false or true is true, think about it like this. We've got an and surrounding these two. The whole expression of this will evaluate to true if this is true and this is true. That's an and, remember? So the whole thing will be true if this is true, if this first bit is true and the second bit is true. That's the definition of an and. Ors are slightly different. This whole expression will be true if that is true or that is true. If either one of them is true, then the whole thing will be true. And is slightly different. And says if they're both true, then the and is true. So an or is like an either. If either is true, then the whole thing's true. So we're evaluating this whole thing left to right. First we evaluate this, then we AND it with this, then we take the result of all of that and we OR it with this. And the result ends up being true simply because this last bit was true. Age was 60. Now, if I do it slightly differently, if I do it the correct way, put the brackets back. Now, remember I said everything in brackets gets evaluated first, no matter what. That's the precedence rules. Brackets always get evaluated first. So now we have to evaluate this first. So, is age 13? Is age less than 13? No, that's false. Is age greater than 19? Yes, that's true. So it's a false or a true. If either one of them's true, then OR must be true. So that's true. The whole thing is true. So this last bit is a true. How about this first bit? Well, we worked out that if we enter Tom, then that's going to be false. So we've got a false and a true, and false and, well, remember with and says that they must both be true for the whole thing to be true. But this first bit was false. So then the whole thing must be false, and you're not special. The whole if would be false if this bit was false. And so we'd end up going down into the not special part. Now I know that was quite convoluted, but that's the nature of logic statements. We've got ifs that contain ands and ors and brackets and what gets evaluated first, and two wrongs make a right and two ands make an or and all that stuff, and it gets very complex. It does. You've really got to have your head screwed on. If you don't like doing this in your head, get out a piece of paper and do it like that. The main thing to remember is that when you're using an and, then both expressions must be true for the whole thing to be true. When you're using an or, then either expression must be true for the whole thing to be true. And as I said, the other thing we need to remember is that brackets get evaluated first. But that's the precedence rules right back when we talked about arithmetic operators. It applies to relational operators as well. Okay, so that is the solution to this program, and it works fine. Finally, let's look at question 3. Remember that this was the code fragment that I showed you in question 3, and I wanted to try and figure out what was going on here. Remember I said x was equal to 5. So if x equals 5, what does this do? I think that was the question. Okay, well let's try and find out. X is definitely 5. Let's run the code and see what happens. Compile, no errors, run. X is 1. How can x be 1 when x is quite clearly 5? We're testing to see if x is 1, and it shouldn't be, should it? Well, x is 5, so 5 does not equal 1, so we should never go into this printf. Now, some of you will have spotted what's going on here. We've got a single equal sign. If we replace it with a double equal sign, compile the program, test it, then we don't get that line x equals 1. In fact, we get no output whatsoever, so the program is now working. So that was the only bug in that particular program. The question is, what did it do? If we put it back like that, what actually is going on here? Well, here's the question. Here's the answer, sorry. This little bit of code here, x equals 1, is not a comparison. If you use a single equal sign rather than a double equal sign, it is not a comparison. It is an assignment statement. It is an assignment statement. It really, really is. Just like this one. That's an assignment. We're assigning 5 to x. Well, here we're assigning 1 to x. We are. We really are. So it's actually, this 5 here is completely ignored because the very first thing we do is we assign 1 to x. So x has the value of 1. It does, immediately. That's all that line does. Well, that's all that expression does. It's not really an expression, it's an assignment statement. It assigns 1 to x. And then the if statement looks at the result. It looks at the value in x. It basically says if x. In fact, that's pretty much what's happening, like that, if x. In fact, this whole bit of code could be rewritten like this, x equals 1, like that. That's the equivalent to what's really going on, except we're not doing it like that, we're actually putting it all in the same if statement. We're doing that. But if it did just do if x, now what would x equal? X equals 1, and 1 is non-zero, therefore 1 is true. Therefore it is always going to do this printf statement, because 1 is always true. It would even work if you did this, if x equals 10, because 10, if you think about it a little bit more, x equals 10, again, we're not doing a comparison, we're just simply assigning 10 to x, and then we're saying, essentially, if x. If x what? Well, if x. X is an integer expression which must evaluate to either true or false. In this case, it's 10. So is 10 true or is 10 false? Well, 10 is non-zero, so 10 must be true, because only 0 can be false. So again, it would print out x is 1, even though x is 10, even though it looks like x is 5. This is an extremely confusing bit of code. Well, if you were to come along and read this and try and debug it, you might get a little bit lost. You might be a little bit confused as to what the program was trying to do in the first place, because it looks like it says, right, okay, assign 5 to x, then test whether x equals 10, and if it does, output x equals 1. It would be most bizarre. That would be a little bit more obvious, and that would be the most obvious, because that would actually be correct. And in that case, the program would work. I hope that is able to be understood.